Yeah, for substrate
Did you
because I'm
did
like
you do the
I
one
started it like a
version?
hot minute ago and it's still because I have a Mac, so I use their one line command and it's
Yeah,
like
it does take a
still
long time. It
going.
takes some time. True. It's going to download. So at first I was doing that every time, and like it would take that long every time I wanted to try a new version or something.
Oh,
But what I
that's
what
a
I
bummer.
discovered is you can actually like clone their repository, and then when you build new versions, it only rebuilds like whatever's changed since the last time, which
Hmm.
does help. But if you're a little ways into it, I'd say probably let it run, and it'll finish in half an hour or something, maybe.
Yeah, pretty. Yeah, I think it's been about like 20, 30, almost 30 minutes now. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, like almost like 10 downloads, and yeah, I'm just
Oh
gonna
yeah,
wait.
yeah. Okay, okay. Well, I was gonna try to find one of these images. Oh, that might not be specific enough. Let's just go here. Because what I was gonna explain a little bit was Polkadot's infrastructure. Here, this will work just great. So, oh yeah, parachain is the word that I was looking for earlier. But anyway, like the Polkadot relay chain, that's this big hexagon in the middle here, and it runs some consensus. In particular, it runs what they're calling this Grandpa consensus protocol. And all of these other chains that are connected to it around the outside, like we've got the triangle and the circle and the square, these are all parachains. And it need not be the case that they're built on substrate, but an easy way to build a parachain is on substrate. And then the idea is each little substrate chain, like whatever we build, or the CryptoKitties one, or the token curated registry one, or the land registry one, or whatever, they don't all have to have their own miners and validators. They can all inherit security from this central relay chain, and then they can all pass messages between one another too. So
Nice.
yeah, so that's a little bit about the Polkadot model, and then I guess I was gonna just try to work through this tutorial that I had started writing. So it's on my GitHub.
So is the relay chain like a public chain you're running, or
Yeah, yeah. So like our chain and like Ethereum, it's sort of like they're developing just the software, the nodes and the protocol and everything, and anyone can spin it up and run it. But their vision is that there'll be like one main or a few mains, like public relay chains that everybody works on, and then individual parachains join on it.
and what's the economic model of the relay chain?
Oh, that's a great question. I'm not sure. I haven't dug in on that yet. It's some proof of stake consensus model. I think there's maybe I'm not sure how the fees work or anything. Yeah, that's a good question. But okay, so the part of it that I wanted to focus on today though is building one individual chain with Substrate. And so Substrate makes it really easy to connect your chains back to Polkadot network, but that's not even also what we're going to be looking at today. So the idea of Substrate is that whenever you go to write a blockchain, if someone wants to write a blockchain, there's a whole bunch of steps that they have to accomplish and pieces they have to code up. And a lot of those steps could be and should be recycled between chains. So like, for example, the part where you're finding new peers and gossiping stuff around the network, all of that stuff could be reused. And if once someone's written a consensus algorithm, it should be easy to reuse that same consensus algorithm on other on other blockchains. And so Substrate is like the base layer, the thing that brings together all that common blockchain stuff, gives you a lot of like pieces that you could put together. They call them runtime modules to quickly prototype a blockchain where you only have to worry about coding like the stuff that's specific to whatever your chain that you're building is. So like, for example, I started digging into this democracy module. And so to write the democracy module, you don't have to write all of the like really low level node stuff. You only have to write Rust code that represents how democracy works. So I think it'll be fun to dive in. So let's see. I basically was going to do like one lesson for each one of these modules that comes in there. They call it substrate runtime module library. And so there's ones for, you know, like for voting or for having a an owner of the chain, like, you know, if this is a test chain or something and you want to be able to easily make changes, then you can like set your private key as the owner that can change properties. There's a couple different governance models or pieces that you can put together to make a big governance model that they have. But anyway, before we do an individual one, I wrote this like substrate fundamentals that'll be a decent jumping off point for us, hopefully. And so, okay, so we start with, it says here substrate can be used in many ways, and this is a link to their, some of their docs, which, Jeremy, if you downloaded, you've at least been near this. I don't know if you've seen this particular doc or not, but basically they're saying like, you can use the substrate that we've already written to spin up your own blockchain, and all you have to do is change like a JSON file for like, what are the original token balances and what are the other Genesis parameters. That's kind of how we've used our node so far. And then modular, and this is really what I'm hoping my tutorial will focus on, although we're going to do a little bit of this first one today. This is where you can take all of those runtime modules, like the ones I was showing, and like glue them together and compose them in interesting ways to build your own sort of chain. And so that's what we're working up to. And then generic is a little abstract. This is where you like really are writing a lot more than just the runtime modules on your own. I haven't dived into this one very much yet. Whoops. But okay, so anyway, if you've run this thing, basically what you're doing is curl is to download this script and then you pipe it into bash. And so I wanted to look a little bit at like what is in this script. You know, the old mantra is like, don't just download code from the internet and run it. Like you always should know what you're executing because otherwise you might get a virus or something. So I did want to look at a couple snippets of the code, and so I looked at some of the more interesting ones. So Jeremy, that thing that's running in the background right now for you that's like downloading and installing the substrate, that's the code we're looking at right now for the installer.
Mm-hmm.
So one of the tools we're going to need, since substrate's written in Rust, is this utility called rustup. And rustup is basically just like a quick way to always have the latest version of Rust and some of the Rust tools. And so it just says like, if you don't have this is the regular old not, right? So if you don't have rustup installed, then download it and install it. And otherwise, if you do have it installed, then just go ahead and update it. And so that'll make sure we have the latest Rust. And Substrate does always target the latest Rust. Like even as I was learning over this past week, I had to update my Rust because I started getting errors that I wasn't getting before because a new version came out. So that's one.
Is this a script that you're supposed to run?
This one right here?
Yeah.
This is part of that thing that you ran. So let me walk you through it here a little bit. So I think probably I sent you this link at some point, right? This is where
that's what I was going off of. So I'm still like downloading all the packages with the curl.
With this one right here, right?
Yep.
Yeah. So what this one does is curl says download this script, whatever script is at that website, and then pipe it into bash or like and then run it. So if we just look at like I'm just going to copy this website and go to that website. And it's just a bash script. So like that one-liner you ran just downloads this script and runs it. And like almost all of it is not that interesting. All of these ifs, else if is just like saying, are you running Red Hat? Are you running SUSE? Are you running Arch? Are you running Mac is down here somewhere, Mac OS? And then like only finally at the very bottom, this is the interesting part. And so this is the part I was pointing at just now.
God.
Yeah, exactly. And then so like, well, we're in here, the last part, and this is another interesting part. It shows exactly what we're going to install. So these are the long steps right here. And so I noticed you can type -- fast to skip the long steps, but then you actually don't get some stuff we want. And so it's going to download from the Substrate Git repository, and it's going to install the tool Substrate, which is the main node that we care about, and Subkey, which is the thing to help us generate key pairs. So like if you guys remember with our chain, in order to generate a key pair, you always had to like start the node and let it boot up and then kill it, and then you could get the key pair. Substrate comes with this thing where I can just type subkey generate, and then it gives me a seed so I can restore it at any time. And then it also gives me the public key and the address that's based on the public key. So,
That's so cool.
yeah, so it's just a little utility to, oh, and then like, so let's say I save my seed somewhere, which is for me just going to be on my clipboard. I just copied it. And then I want to like restore my key later. I can do subkey restore and that type, oops, no space. And then it tells me back the same, oh, wow, that doesn't look like the same key. Oh, that's weird. I don't know how that works. Oh, every time I restore, oh, wow. I wonder, so I know Substrate recently switched from the ED25519 to the SR25519 keys, and I'm curious if that's what's going on. I thought maybe it would say how we could specify, but I'm not sure. I was a little bit surprised to see it didn't give me the same key, but that's okay. Oh, where was I? So, yeah, so this is the part I was just talking about. And, oh yeah, and finally, the last thing it installs is Substrate Up. And Substrate Up is a really cool set of utilities that help you, like if you want to start writing your own runtime module, you can type substrate module new at your command line, and it gives you like a whole template of all the code you need. So you don't have to like create all the folders and directories and configuration files and stuff. Okay, so here's where it gets hands-on and kind of fun. So Polkadot and Substrate, well, Polkadot wrote this, but it works for Substrate too. You can use this interface in a web browser to interact with their nodes. So I have this link here in my tutorial for the hosted interface, and it'll take us to this website. So in case you're not on the tutorial page, I'll drop that into the chat too, maybe. There. And so you don't actually have to have Substrate installed locally to use this thing. Let's see. So mine was set to local node only because I've been doing this before, but did anybody else go to this website?
I'm on it now.
Nice. So by default, it starts on Alexander, which is what we want to look at first. And do you see anything more interesting than what I saw going on, Jeremy?
No, we're looking at the same thing. Alexander, default interface, pocket dot, featured full, yeah.
Oh,
so
yeah,
we
nice.
got
So now we have this Explorer tab. Does that show up?
But yeah, I also see the Explorer, but I wonder for the custom. So I guess when we create our own node, you can just point it to the endpoint.
Yeah, bingo. That's right. So you can, it communicates over WebSockets. So anywhere you have a node running, you can point it at your node and communicate with it.
Now, this is also for like, obviously, if we wanted to create our own like private connection. So,
Totally.
Okay.
Yeah, that's right. So one thing I played with for a while was like trying to start a node on my laptop and another one up on DigitalOcean. And I got that to work a little bit. And, you know, it took a little bit of work, but yeah, then you can like have an interface on each one, or you can swap which node your interface is connected to.
I would like to actually do that at some point.
Totally, yeah, I would love to do that. I would love to do that too. So we're going to learn a lot of the like get familiar with what those steps will look like, and then that can be an exercise soon. What I really want to do is set up a DigitalOcean container that has like the thing already installed, so then we can just make copies of that container and not have to run the install script a million times because it takes so long. Okay. But anyway, so on this Explore tab, we can see that like our target block time is 6 seconds. So in Bitcoin, that's 10 minutes. In Ethereum, it's 15 seconds. And it's totally customizable we can just change a configuration file. But you can see like a new block gets mined roughly every 6 seconds. So that one took a little longer, and now we've got a new block coming up here. And I want to, I lost my tutorial. I want to try to go in the order of my tutorial just to make sure it makes sense, because I was about to get ahead of myself and talk about token transfers. So, oh yeah, so one thing I wanted to point out here is this is mostly how I've been interacting with the node, like to get familiar with it and to play with it. There's also there's a second interface that's also on GitHub that it does all the same kinds of things but looks a little bit different. And then there's also just a JavaScript library. Like this is basically their version of our chain API that we had used to interact with the node. So you can write JavaScript programs to like automate things that you might do with your node. And so I'm hoping we'll get to look at that a little bit today too. So, all right, so we can actually go ahead and start up a chain now, right? And so this is going to be a chain a lot like the one that was running on the robot server for a while, where it's basically like one node with one miner, sort of like a blockchain of one. And there's still lots of interesting things you can do, especially like prototyping and experimenting with your your dApps or your runtimes, as they're calling them here in Substrate. So it's once it's installed, it's super easy to start the chain, and so I'll just go ahead and do it.
And I'll let you know once it's done installing on my end.
Okay, cool, yeah. All right. So this is a little bit of like what the log looks like, and you can see in some ways it's similar to our node, right? It just says like, here's the Substrate node, here's what version, including the get hash, just like our node does. This is like their equivalent of the R node address. Oh, one weird thing though, so our node makes an attempt to guess your public IP address, and Substrate doesn't do that. So like if Jeremy had his thing installed and wanted to connect to me, like I could give him this R node address, or well, it's not called R node, but like this address to just bootstrap from, but he would have to replace the 0.0.0.0 with my actual IP that I would have to look up.
Also, so I noticed on the top, sorry to interrupt, under roles authority.
Yeah.
Does that mean just like you're just like the owner of that node itself, or?
Yeah, that's a good question. So it's saying that, so one thing that's implicit when you type --dev, it starts your node with a validator key. So in our node we have to do like --validator private key, and then you type your key. When you type --dev, it uses a pre-built validator key for you. And so I think it's making us authority there, and authority is like pretty.
Like
I'm
a
not
pseudo.
Sure. What's that?
It's like a temporary pseudo for your environment.
Oh, they have a pseudo module too. Totally. Yeah, I think authority has to do with their consensus. It's sort of like being a validator, basically. So we can actually check that out. Let's see. I want to look at the staking thing here. Oh, they are calling them validators here, so I don't really know exactly what authority means, actually. Yeah. But so like you guys have come to community node testings, we're always trying to see like who the set of bonded validators is. So this interface will do that for us too. So it shows us like these are the 5 validators in this network that we're on. So, okay, so let's connect to my local node. So now we're not on that public Alexander network anymore. Now we're on this one that's just on my computer. And oh yeah, there you go. And so I'm the only validator in here. Alice is the key, the name that I used. Yeah. And apparently mining blocks just fine, or validating blocks just fine. So like back in the log, we can see like a lot of similar things. So this is like found a block right here. Then they're starting to run their consensus on top. So in our node, this would be Casper, and here their consensus is called Grandpa. And so this is going to look the same for a long time, right? Like there's no other peers, so nothing too interesting will happen there, and the block number just goes up, 448, 449. And then, well, actually, let's scroll to the bottom and see. So we're on block 486, 487, and you can see 487 just got created by this validator, and that's the same block it shows over here. So, okay, so cool. So we've actually got a blockchain running there. And now, like, we can just start to play with it and deploy stuff to it.
So It's making empty blocks.
Yeah, yes, that's right. These blocks are so they're empty of transactions because I haven't been submitting any transactions, but they do have what Substrate calls inherents, which is data that comes in other than transactions. And so like the most obvious example is like the timestamp. So every block has a timestamp that goes into it. So all of these blocks have those as well. But yeah, they don't have any like transactions from users. Yeah, that's a good question. Okay, but so now let's actually make some transactions from users. So on the transfer tab, okay, right. So one of the modules that comes with Substrate is called balances, and it basically allows users to have token balances, just like your Ether balance or your Bitcoin balance or your Rev balance or whatever. And on the Polkadot network, the token is called dots, and since we're just on our private Devchain, we can just call them tokens or units or whatever. But okay, so right now we're being the Alice account. That's the key we use to actually start mining and everything. There's a couple other accounts that come preloaded here. Alice, Bob, Charlie, Dave, Eve, and Ferdy. And then earlier I made one of my own, and we'll see how to do that in a second too. But I think I don't have any accounts. Yeah, since I just made this one, I don't have any balance on my account. So like maybe our first transaction is that Alice will give me some of her tokens. And so just to show an interesting thing about Substrate balances module, let me try to transfer like 3. So Alice has 1 point something million, so she has plenty of tokens. But I'm getting this warning here. The final recipient balance is less than the existential amount and will not be reflected.
Hey, Joshie, quick question. I'm still on the Polkadot site. So I'm not sure if you can maybe open up a new tab on the chain state.
Yeah.
So I'm looking at balances and creation fee, and it tells you how much I think it is. It's not necessarily descriptive from what they say. So when you go into chain state and then select state query balance at the top,
yeah,
then you go to creation fee.
Yeah.
And when you hit the plus, I guess you need a lot. So I'm not sure if it's like, does it break down like how Ion has like, you need like 10,000 where it all kind of converts down to like, 10 tokens.
Oh, wow.
I think that helped.
Okay.
Yeah.
Hey, can you share for a second, Jeremy? Because I actually, on my local chain, I see 0 for the
okay. I'm on my phone, so I can't necessarily share.
Okay.
Actually, I'm gonna connect my laptop to it as well. So just give me a moment.
Oh, sure. Yeah. That sounds good. Okay. In the meantime, I'm going to submit this. I know the interface is warning me that this isn't going to go through. I'm going to go ahead and try it anyway, just to see what happens. So those like 5 or 6 accounts that came preloaded all have the private keys already installed, so we can sign things on their behalf. This is just like a convenience to play with the network. All right, so the node has received it. Okay, it says finished, and then it says extrinsic failed. And so extrinsic basically means it's kind of like transaction, but it also includes those things I talked about earlier, like timestamps and stuff that doesn't come from users, but is still like in the blockchain. Okay, and so it said it failed for exactly this reason because.
All right, I can mind if I take over real quick?
Yeah, go for it.
All right. So let's do the screen. All right. So yeah, so when I go under balances, you see obviously like creation fee. When I hit the plus button, this came back with the actual
Oh,
fee.
wow.
Also, reserve balance. And not let me do anything for that. Let me click out. Transfer fee. So I guess that's also the transfer fee as well.
Oh, I didn't realize
it's not necessarily
that makes sense.
Clear on like exactly what it is.
Yeah, so I can help a little bit here. So that list you have open right now is determining which runtime module you're going to query something from.
Mm-hmm.
And so you did the balances one first, which that's the one that is responsible for like token transfers and token balances and that kind of. Yeah, perfect. There you go. So we could see like Bonding duration. Okay, so I guess that means if you're going to bond to become a validator, you have to bond for at least 600 blocks or a multiple of 600 blocks or something. And it
Yeah, that's
tells
what
you
I'm saying. Like, it's not necessarily like clear on like what it. Well, I mean, maybe it's in the documentation somewhere, I'm sure.
See on the right side of that drop-down menu, those strings come from the Rust code themselves, and they give you a little hint, but most of them get. Oh, awesome! I didn't realize it would do that tooltip. The length of the bonding duration in blocks. Okay. Nice. Okay, so we'll have to have at least one validator.
Sure, which makes sense. So I'm curious. Let me go back to balances while we're on here.
Yeah.
The fee required to create an account. Okay, so all right, now it's starting to make sense.
So the error that I had was existential deposit. So what is that one? Yeah, okay, the minimum amount allowed to keep an account open. So I think Alice was trying to transfer me 3 tokens, but 3 isn't enough to keep my account open. Definitely not on that chain.
Yes. Oh, I wonder why. Let's see, vesting amount. All right, cool. I wonder why it wouldn't show up for yours, but let's see. Key. All right, cool. Yeah, that's all I wanted to like share. I thought that was
Oh, nice.
pretty interesting.
So yeah, so let's I'll take it back and then let's see what some of them do on my local node here. So well, okay, actually, let's have Alice transfer me enough tokens that they will go through. So we need to do what Jeremy did and say, what is the existential deposit? Okay, 500 tokens. Great. So Alice will transfer me 1,000. Oh, nice, and that warning goes away. So she'll sign it. So waiting for a block. Hey, there we go. And extrinsic success. So that's basically like saying the transaction succeeded there. And so now we can see that, hey, I have 1,000 tokens. Hooray. Yeah. And then sometimes it shows us recent events here, but I think I just didn't get there quick enough to see that transfer go through as a recent event. Okay, so like some of these tabs here are nice interfaces that people have written. Like this is a pretty nice interface for transferring tokens.
Mm-hmm.
But some people write runtime modules and don't get around to writing interfaces yet. And so this Polkadot interface also provides like a lowest common denominator. So even if you haven't written a nice one like we played with here, there's always this minimum user interface over here. And so it's called extrinsics. And so again, extrinsics are either transactions or what they call inherents, which are, the timestamp, for example. And so we can submit arbitrary extrinsics right here. And so the way we read this is like, Joshi is the one that's gonna, well, let's make it Alice because she's got some superpowers here. Alice is the one who has 1 million tokens, and she's gonna submit the following extrinsic, which is the bottom half here. So we could also say like, to the balances module, we want to transfer, and then you notice this transfer function takes 2 parameters. So like, who's the destination, who are you transferring to, and how many tokens. And so then it gives us an interface to specify, I'm paying the tokens to Charlie, and I'm paying him 67 of those tokens, or something like that. And so we can submit that transaction. And then this one will go through just like the transfer did when we used it, when we did it using the nice, clean transfer interface. So it's kind of neat that like when you're first developing your runtime, if you haven't gotten around to writing a sexy interface like this, there's still always something that will get automatically generated so you can play with your runtime right away. So I thought that was kind of cool. Okay, so let's see. Where did I leave off?
Is that generated from the Rust code, or?
Yeah, yep. Yeah, and I don't know exactly what all the intermediate steps are. I think it somehow you write the Rust code, and then somehow there's a step where like equivalent JavaScript things get derived from the Rust code. And I don't know exactly how that happens, but then once it's in JavaScript, then this interface is able to detect what's possible. So oh yeah, right. So I was talking a little bit, like we started with this. We started with substrate -- dev. And -- dev is just basically like a convenience flag. And the longer way to spell it is like this. And so what we really told Substrate was we're going to run the dev chain, which means it's like a profile of a chain. Substrate knows that, okay, Alice is the only initial validator, and there's some preceded token balances, and it has these couple of runtime modules installed. And then we told it we want to be a validator, and then we told it that we want to validate with Alice's key. And normally you have to type an actual key here, just like you do in our node, like one of those long hex strings. But there's a few special ones, the Alice, Bob, Charlie, etc., that you can also type this way. Okay, so here's an exercise. I said in addition to the dev chain, there's also a staging chain. Let's try that out and see what's different. So I want to give that a go. So we can kill this one just like we usually do with our node. Oh, real quick, I'll show you. If I run the dev chain again, notice it left off at block 663. It picks right back up where it left off. So that's the same as the feature that just got put into our node where they save the blocks. So that's kind of cool. But okay, so let's try the staging chain now instead of the dev chain and see what happens. So I haven't run this one before, so we're starting at block 0. And then let's see what the interface looks like. Oh, for one thing, there's no blocks forming, and that's because I didn't use -- validator this time, I think. In staking, okay, it looks like there are 4 bonded validators this time. I don't know if one of those is Alice or not. Let's see, Alice is 5GRW. Yeah, I don't see Alice in there. I wonder if I know who these people are. 5CFY. Yeah, okay. So I don't see those addresses in here. So I think that means we're not ever going to get to make any blocks on this chain. And I thought maybe we would see a few different tabs because of different runtime, but maybe those are the same. Did we have any other tabs here before?
Nope. Well, also, I'm not sure if you just saw my message, but it's finally building and compiling. So I'm gonna give it like a couple more minutes.
Oh yeah, your Rust is building. Yay! Nice, dude. That's great. So it's all downloaded. Good.
Took forever.
I know. Oh wait, this is where I wanted to go. Okay, so we tried the staging chain. Nothing too interesting there. The point was though, Substrate node comes with a couple different built-in profiles. So we've seen dev, we've seen staging. We already did this transfer the tokens thing. Oh, we didn't see how to add an account in the UI. It's not too crazy, but you know, it's worth knowing how to do. So maybe I'll make a key for Jeremy here. And your password is a mystery. Okay, and so then it creates this new account. It gives you your address. It gives you this like visual thing as a quick way to know what your address looks like. Make sure you didn't typo it. And then it gives you an opportunity to back it up. And when you back it up, this is just a junk key, so it doesn't really matter if I, you know, show it or whatever. But so it's saved to my desktop. Oops. So in that file, it has your address, 5HSB. That's the same thing that was right here. And encoding, I don't really know. you know, what the options are there or anything, but it's telling us it's an ed25519 key, so that's good to know. And it contains the human readable name and when it was created. So this is just like a little file. This is the kind of thing that you'd like put on your flash drive and hide away somewhere, or trust your hardware wallet to keep track of, or something like that. Oh yeah, okay. So another thing I wanted to show is about this interface that we're using. It works great to use the hosted one in most cases, but there are a few bugs. You know, like everything, this is just like all these blockchain projects. Like, it's still under development, it's moving fast, and so you know, things change. And so if you want the latest version of it, you can. Oh, I even have it running right now. But it's just something you can clone. So, like, I got this from GitHub. You can see that there are some, you know, regular old commits and everything. And then it's just a JavaScript project, so you can do yarn run start. This is basically the same as npm run start, but they use yarn. I guess has some extra features that are needed in this case. And then so it'll boot up just like all those Node apps that we've worked on, and then you can look at it this way too. And so, you know, if it's just a good thing to know, I guess, to get new features or to hack on it or to work offline or something. Seems like it's taking a long time to load this time though. There we go. And it looks exactly the same, you know, nothing has changed really. So, oh wow, there we go.
Although silly question, even though you can do like local tests, can you also just do like offline, whereas you don't necessarily want to connect to the global chain, but it's like 5 of us just want to work, I guess, locally?
Totally.
Do it?
Totally.
Okay.
Yeah, absolutely.
Or offline per se?
Yeah, well, I mean, we would still need the internet to reach each other, but like you're saying, like separately from the chain or a public chain, or like just our own little. Mm-hmm. Totally. Yeah, and so in fact, like, I mean, really, that's what I'm doing right now. I'm just a little test net of one all by myself. But yeah, I could totally just give you that address. Remember when it started? Oh, where'd it go? If I just give you this, and then you can.
Yeah, can you copy and paste that over? Even though it's like still building, I'm gonna try to see if I can connect to you.
Yeah. Mine is. Hold on. We can do that, but this one on my laptop will not reach the internet. But this is what I can do. I have one on DigitalOcean.
It doesn't do peer-to-peer connections with the WebSocket?
Oh, yeah. What was that?
Doesn't it do peer-to-peer connections with WebSocket?
Yeah, it totally does. Something is wrong with my configuration here at home, and I don't know what it is, but I can never get those ports to open up. I just haven't figured it out. It's totally a on my end thing. Oh, and then there's also this flag, --WS external, which means if you want to connect the interface from somewhere other than on the same physical box, this makes the WebSockets visible outside too. So Jeremy, now I can give you this one. I'm gonna just drop it in Discord, I guess, in my substrate channel. And then and remember I was saying you got to change all those zeros, so I'll do that for you. Boom, there we go. Do you want to take the screen share while you try to do it?
Yeah, well, like once it's done building, it's like almost done.
Oh, it's still okay.
Whatever.
Yeah, it's still building. Okay.
They're doing that parity codec right now, so.
Oh yeah, that's one of the parts it's compiling. You're saying?
Yep.
Nice. Okay.
So once that's done, I'll take over the screen share.
Cool. Yeah, just interrupt me whenever it happens, and in the meantime, we can keep going on dev. Oh, here's a good thing to show. So I was going to start the dev chain again, but I want to throw away all those, like we're a couple hundred blocks in and I want to start fresh. So there's also this command instead of just, I mean, you can delete the folder just like we do with our node, but you can also do this. Substrate purge chain, and I want to purge the dev Devchain. It says, are you sure? Tells me where the Devchain is stored. Am I sure I want to delete it? So I'll say yes. And now if I run it again, then it's going to start off on block 0 this time, hopefully. Yeah, nice. All right, and so now I have my block number 1 and block number 2, and we're off to the races again. So this is a cool part. Yeah, I'm going to skip the JavaScript queries for a second. Maybe I'll just show them like this. There's this tab called JavaScript, and it gives you a bunch of examples you can choose from, and they're just examples of how you can communicate with your node from your own script. So for example, if I want to listen to Alice's whenever something changes for Alice's balance, I just make a string representing her key, and then we do api.query.balances.freebalance of, and then that string that represents Alice's address. And that's it. So this gets her initial balance, and then what they do here, I think they're just gonna do balance.sub, so they like subscribe to the balances. And I think what previous does is like tells it the last one they knew. Let's just run it and see. But yeah, so it tells us Alice has a balance of that, and then I know that if I change tabs, this is going to go away. So instead, what I'm going to do is open transfer over here, and then I'm going to send something to Alice. So maybe Ferdy can send some tokens up to Alice. And I think what we're going to see in that original tab is a notification. Okay, extrinsic success, that's good. And oh yeah, look at that, new transaction of however many that is. So one way to run the JavaScript is here in the browser, and this is super convenient when you just want to type something real quick. But a more serious way to do this is to actually install the Node.js code, and so I've linked to that in my tutorial too. And and they have a ton of examples, so it's one of those cases where I was pleasantly surprised to see that it really was as easy as copying their example and running it, and it worked. So, okay, so we're almost to, it's 4:45, so I do want to talk about the chain spec here, chain specification. And so we've noticed there's a bunch of properties about the Devchain that we've been using. So for example, like Jeremy showed us that the existential deposit was 500 tokens, and I don't know, what were some of those other ones we saw? Some of the fees.
Staking. They even had, let me go back over here. Consensus. Actually, they only have like original authorities, whatever that means. There's not really much of a description on that.
Oh yeah. Which one are you looking at, this interface?
Yep.
On chain state?
Even if you do Pseudo, it tells you your account ID.
Oh yeah. Oh, you know what this is? Oh, I'm glad you brought that up. This is going to tell us who is the super user, like who's the king or queen. I think it's Alice. It's 5GRW. I think that's Alice. Yeah, totally. Oh, and in fact, like we can even, let's play with that module a little bit. So if I want to go to the Pseudo module and I want to say the new key, like we're going to make the new king Bob or whatever. So remember, extrinsics is how you submit like arbitrary transactions that there might not be a nice interface for yet. So we're going to say the Pseudo module we're going to call the set key method, and that's going to change the key to Bob. And if we remember right now we're deploying that as Ferdy, and so if I sign and submit, I expect this to fail, and it did. Extrinsic failed, and the reason is Ferdy isn't Pseudo. Ferdy doesn't have the permission to change the super user. But Alice does. And so if we try the same transaction as Alice, now it says extrinsic success. And so if we go and do the Pseudo thing and we say, yeah, see who the account ID is, then it tells us it's 5FH. And 5FH is Bob now. So now Bob's the king, not Alice anymore. Okay, cool. So So anyway, there's all these properties. Like for example, the super user started out as Alice, and the creation fee is 0, and all these things. And so when we start a new blockchain, we want a way to specify what these values are going to be at Genesis. We know we can change them by using Pseudo or something like that in some cases, or a different governance method, but we need to set them in the Genesis block. And so that's what the configuration file or the chain spec does. It's just a big JSON file where we can change these numbers. So I'm going to kill my node. And we could just open up a new file. Oh, yeah, go ahead.
Out of curiosity, because now I'm thinking about the JSON files, is it possible, doubt it, but is it possible to create like a time to live on a node? So like, for instance, let's just say Alice goes down, it transferred, I guess, assuming that I'm understanding Pseudo in this system correctly, transfer over the keys to, let's just say like, myself or Jim.
That's an interesting idea. So you're saying like, if Alice is the Pseudo right now, but like if she gets hit by a bus and suddenly there's no transactions from her for a certain period of time, then like automatically.
Yeah, I mean, it's essentially making it like more decentralized as well, right? So it's like,
totally.
Hey, I'm gonna keep one running on at Jim's house because he has a backup generator. So if my computer ever goes down, our private network can keep going. So I wonder if that's something you can do create the custom JavaScript for.
Yeah, well, so the way that's such a good question. There's so many ways to go from there. So one way to do that would be to write your own custom runtime module, which isn't that hard. It requires some Rust coding and then recompiling. And that's the kind of thing that we could totally do as a future exercise. Another similar thing that's not exactly what you described but might still be interesting is well, let me get back connected to a real node. We could use the governance module to do just exactly that. There we go. So one thing, the way the governance module works, this is actually what I was hoping to talk about. I got to decide where I'm going. I think I'm going to show governance real quick. Oh, but that's sorry, I meant to talk about democracy, not governance. Okay, so there's this diagram, and this is like all of the people in the network, right? In a public network, that would be huge, but in our hypothetical private network, that might just be like the 6 of us or something like that. And so anyone can make a proposal, like I propose to change the super user to Jim because Alice has been gone for too long. Or I propose to increase the token supply to X or decrease it to whatever, or change the block time to something different. And people make all of these proposals, and there can be a lot of proposals at the same time. But, people don't really want to, like, have to vote on every stupid issue that anyone dreams up. Like, I might propose that I want to have 16 decimal places of precision instead of 15, and people just don't care about that. And so when you're interested in a proposal, when you say, like, yeah, this is a good thing that we should talk about more, then you can put tokens on it, like put your tokens into the contract and lock them up so that you can't spend those tokens anymore. And every so many blocks, and that's another thing that's configurable, by default it's 9. So like every 9 blocks, whichever one of these proposals has the most tokens locked up behind it becomes what they call a referendum. And all those locked up tokens are given back. And so now we have an actual election, and the coin holders get to vote on, like, do we want to pass this proposal or do we want to stick with the status quo? So like the example of a kind of proposal you could make is like, hey, the person who has the pseudo key appears to be gone. Like, I propose we change the super user or something. Yeah. In fact, maybe we can even do that one as an example. But okay, let's look at the chain spec real quick though. So to make a chain spec, we could start with an empty file and type the JSON ourselves, but it's impossible for me to remember all the stuff that goes in it. So what I like to do is start with the one that represents the Devchain and then just make changes to it. So you can do substrate, build spec. Oh, and by the way, like, it's no one's going to remember these commands having seen them once. So there's always this substrate -- help. And it tells you all the stuff you can do. Like, we've done build spec, we've done purge chain so far, we just did help. I haven't messed with export or import blocks. That could be fun though. So anyway, I'm going to substrate build spec because I'm going to build one of these chain specification JSON files. And I want to build the one that comes from the dev chain. And I want to write it to a file called like custom spec.json. Boom. So now I have, whoops. There we go. Now I have this file called, there it is, custom spec.json, and it's like, it's kind of big. It's like almost 2 megabytes big. And so let's just look at it in the text editor. Oops, this is the one I did earlier when I was making sure I knew my stuff. Here's the one we did just now. And it does take a second to open because it's a little bit of a big text file, but we'll get it in a second here. Hopefully. Yeah. Come on. All right, let's try it. Let's try it here. All right, there we go. So there's a couple different things we can change here, and the first one that I want to change is one that's pretty easy to understand. It's called the period. Basically, this is like the target block time. And because of a known bug, it's always actually going to be double whatever we typed in here, at least for the time being. But like, for example, I'm going to change this so that instead of saying 2 seconds, it says like 5 seconds. And, you know, again, remember, it's always going to double. And so that means our block time should be about 10 seconds if we restart our chain. So I'll save that. And then I also want to go to the end of the file. And down here near the bottom, there's other interesting things that we can change. So like grandpa is the consensus algorithm. And we were saying the authorities are like, I don't really understand the relationship between authorities and validators yet. Hopefully we'll figure that out at a consensus meeting soon. But we can change it anyway. This is just Alice right now. She's the only one. Council we haven't talked about yet, so we're not going to change those. Democracy is the one that I've been digging into, and so here's some properties we can change there. But here's another easy one to mess with, and it's the balances. So right now everybody starts with this same number of tokens, and I'm just going to change this so that everybody starts with a different number. So Alice starts with 1 and a bunch of zeros, Bob starts with 2 and a bunch of zeros, and we'll do one more. All right, so we've changed the block period. We expect it to be 10 seconds, and we've changed the starting balances for Alice, Bob, and Charlie. So we're going to save that. I'm going to clear my blockchain so we can start over. And then before we can start up with that custom spec we just made, there's one more step. And again, this is one that I don't totally get, but I know how to do it. We have to do this again, build spec. We tell it the file we just did, which was, whoops, custom spec. And we give it this raw flag. And I don't really understand the difference between raw and the human readable one or why it's important, but I know if we do this, it'll work. So I'm going to call it custom raw.json. And basically, we're taking this JSON file we just created and somehow transforming it into a different format that's the format that it wants. And then we're going to do substrate chain equals custom raw.json. So instead of --dev, now we're using our own custom chain here. Starts over at block 0 because I cleared the blockchain. And let's look at the interface. Oh, wait, I'm connected to the wrong one. Oh, interesting. Okay, so this is cool. Our target is 10 seconds. That's what we wanted, but something is worse than before. We're not getting any blocks this time. And that's because I forgot to say we want to be a validator and we want to be the Alice key. Oh, maybe you can't do the Alice key that way. I have to, sorry, hold on. I have to get the Alice key, which is a little bit of a trick at the moment. All right, once that thing loads, I can come over here and I can copy this. Maybe. Here, that'll do it. I think that'll do it. No! Oh, that's an address. Okay, I got myself a little confused. I don't remember how to do the right Alice key. Shoot.
Can you go back into your terminal again?
Yeah.
Or your JSON?
Oh, yeah, in the JSON file? Yeah, totally. Oh, great idea. Yeah, where did I have that file open? I can just do it here. Oh, custom spec. There we go. Oh, it has these. Yeah, what did you want to see, Jeremy?
I just wanted to see where, do you have to specify who's going to be a validator in your key as well?
Somewhere, I don't know why I didn't find that. Somewhere down here it specified authority. Oh, there's the pseudo key. That's where it says that Alice is pseudo. Oh, here we go. That's what I was looking for. This is where we said that Alice was the grandpa authority.
Mm-hmm.
Oh,
I'm assuming that we got the minimum amount they need all correct.
yeah. I just had an idea. I just want to look back through my command history. Boom. I knew that would be in here somewhere. I think that's the Alice key that I want, but we're going to see. Let's see if we get any blocks. Yay, okay, we mined a block. That's great. So we found the correct Alice key, and I'll be honest with you, I don't know the fully correct way to get that key, but I'll show you how I got it before. That was coming over here to Riot. This is basically like the this is where this is the Discord of the substrate thing. Oh, I thought I would be able to copy a link and send it to you guys, but you can get here from from parity.io/substrate. They link to it. And someone popped that key in here at some point. So I don't know exactly the right way to find it yet. But that's okay, because we're mining blocks now. Hooray. Okay, and great. Look, so our target time was 10 seconds. And if we look at our balances, then we can see Alice has, that number that starts with a 1, and Bob has the number that starts with a 2. And so all those things we typed in our JSON file actually did have the effects that we desired. Yay.
Also, does Substrate have a built-in API as well? We just wanted to just connect to it, create a web app to connect to it?
Oh, yeah. You mean if you wanted to create an interface in the browser that wasn't like this whole polka dot thing that was for your specific application?
Yeah, if you wanted to make our custom private one, you'll be able to connect to an API, or that's something we have to build out ourselves?
No, it totally has all of it. So anything that we can run in the JavaScript tab over here, you can use all of that same data behind the scenes in your own UI. And in fact, I bookmarked this one. There's this workshop called the Substrate Collectibles Workshop. And it, oh, this is what I meant to go to though. This is where it's hosted. You make a clone of CryptoKitties using Substrate, and it walks you through the process of writing, first of all, your own runtime in Rust, and then doing the part you were just asking about, Jeremy, where you write your own user interface that runs in the browser that connects to the blockchain. Yeah. So it's going to end up looking something like this, which is, it's pretty cool. I'm only partway through this, but it's relatively straightforward to follow. So.
Awesome, thanks.
Yeah. Oh yeah, no problem, man. So okay, it's 5. We could end here, or we could try to make more peers in the network if yours is running, Jeremy, or we could do democracy. What's everybody?
I mean, mine is still, it's at 5:35. I'm like, oh, so long.
Yeah, that was my one. That took me a long time to get going because, like, so imagine you sit through this and you like get pretty good at it, and then in a week they're like, hey, we came out with 1.0, and you're like, oh, I want to try that, and then you got to go through all this again. So
yeah, I mean, I've been downloading stuff for like almost an hour now. But you said it was faster just to clone the repo and build from there, right?
Well, here's the difference. The very first time you do that, it won't be any faster. It'll be the same. But the beauty of it is that then every time you like grab a new version or make a change yourself or something, those subsequent ones will be much, much faster because you only have to recompile the parts that changed.
Oh, okay, that's cool.
Yeah. So and in fact, like I can show you about how to do that. So I'm gonna kill my node here. So this is like just my workspace, and I'm pretty sure I would have done something like git clone and then whatever, I don't remember exactly what it is, but something like github.com/parity/substrate or whatever it was, and it would have run that command and made this folder for me. So now like this is their GitHub repo. It's all the stuff that's on their GitHub repo. And then if I want to compile it, I just have to do cargo build. I'm pretty sure that's all I have to do. And look at, well, I mean, so that time it took no time at all because literally nothing changed. But if I had made a small change, it would have only recompiled those little tiny parts.
Gotcha.
Yeah. So we'll see how much interest there is in doing more Substrate sessions, but I'd be happy to help people.
No, I would like to definitely look at it some more. So I'm about to say maybe during the next call is going a little bit faster. Never mind, stop. But maybe during the next call, we could just do like a raw tutorial of just how to get it set up. So I do want to kind of play around with it, but it would be a good idea, like just to do another recording and say, all right, you first wanted to connect. Hey, come join our network. Here's exactly how you do it, like step by step.
Yeah, I agree. That's a good idea. And so steps that I can take to get ready for that are to get like a DigitalOcean container that has all the stuff installed and running. And that way, if people show up that are new that don't have it installed yet, we can just be like, hey, here's a DigitalOcean container to just use like for the day, So
that'd be cool.
Yeah. Okay, well, I'm getting the sense maybe we can end here. That was a really good start, and we made it through my whole first lesson. So, guys, thank you so much for letting me talk about Substrate for an hour.
Anytime. Thanks for having us, man.
Yeah. All right. Should we end the recording, Jim?
Yeah. Where are we?